Hello everyone. In this session of CCNA series, I'll discuss about wireless bands and channels. And also I will discuss about non-overlapping channels and channel bonding. Wireless signals occupy a wide range of radio frequencies. These ranges of radio wave frequencies are used to transmit data in the wireless spectrum. As explained in my last video, frequency is nothing but the number of times the signal vibrates or make one complete up and down cycle in 1 second. If the signal vibrates very slowly, it has a low frequency. If the signal vibrates very quickly, it has a high frequency. So frequency is measured in hertz. As an example, FM radio signals vibrate around 100 million times every second. So the FM radio operates on 100 megahertz band. Similarly, wireless LAN or Wi-Fi uses two bands at higher frequencies, 2.4 GHz and 5 GHz. 2.4 GHz band operates between 2.400 and 2.4835 GHz. Similarly, 5 GHz bands operate between 5.150 and 5.825 GHz. Bands are nothing but a range of frequencies. Wireless bands can be further broken down into channels. In case of wireless LAN, we call it Wi-Fi channel. These channels can overlap and cause the interference. Let me explain this with an analogy. Each channel is similar to a room at a party. If one room is crowded, it is hard to carry on a conversation. You can move to the next room, but that might be crowded as well. As soon as the building is full, it becomes difficult to carry on a conversation at the party. So for the 2.4 GHz band, there are 14 channels in total. Unfortunately, these channels overlap. So they aren't all usable at the same time. Wi-Fi channels actually represent the center frequency that the transceiver uses. Example, 2.412 GHz for channel 1, 2.417 GHz for channel 2, etc. There is only 5 MHz separation between the center frequencies, and the signal occupies about 22 MHz of the frequency spectrum. As a result, an 802.11b or G signal overlaps with several adjacent channel frequencies by 11 MHz on each side of the center frequency. This leaves only 3 non-overlapping channels, 1, 6, and 11. These non-overlapping channels are far enough from each other and they have sufficient space between the channel centers and do not overlap. Channels 2, 3, 4, 5, 6, 7, 8, 9 and 10 all overlap significantly, causing adjacent channel interference. So if you are a wireless engineer and planning a wireless network, do check what channels are most in use and plan your network to use a channel that doesn't overlap. Next, let's discuss about 5 GHz band. It is much wider and includes 24 channels, which makes it easier to select a channel in this band that doesn't cause interference. The 5 GHz band actually contains the following 4 separate and distinct bands: 5.150 to 5.250, and the second one 5.250 to 5.350, and then we have 5.470 to 5.725, and then we have 5.725 to 5.825 GHz band. Each channel is allocated a frequency range that does not overlap the frequencies allocated for any other channel. In other words, the 5 GHz band consists of non-overlapping channels. Since there are more channels available in 5 GHz radio, the client and AP can combine multiple adjacent channel to form a message, multiple adjacent channel to transfer a message and achieve high speeds. This is called channel bonding, and this is essentially one of the reasons behind higher throughput for different standards. That's it for this session. I hope this was